In this presentation, we're going to use the ratio test to test this following series, this one here. Okay, we're going to test that for convergence. Okay, I'm going to talk about how to test it later on, but essentially the first thing we sort of need to remark upon is this is the general term, u of n, and it is 5 to the n over n factorial. Okay, so that's important to start off. So what I'm going to do now, that just get clear, clear what the series is and what the general term is. Now, what I'm going to do here is I actually started this, but I have a little error there somewhere, so I'm just going to sort of restart this here again. So first off, we have u of n, and there it is again, 5 to the n over n factorial. What I'm going to do is actually later on we have to divide two terms, and the term I'm dividing by is u of n. But similar, division is also multiplying by 1 over something. So I'm just expressing 1 over u of n as n factorial divided by 5 to the n. So essentially just flipping this expression here, just flipping it around. Okay. Now, the next part is u of n plus 1. So what we're up here, where I have an n, I'm going to replace it with n plus 1. Okay, so I have 5 to the n, so now I'm going to replace that with n plus 1. And I have n factorial, I'm going to replace that by n plus 1 factorial. Okay, now I'm going to re-express that expression here, 5 to the power of n plus 1. That's the same as 5 to the power of n times 5. Okay, and n plus 1 factorial is n plus 1 times n factorial. Okay, that's going to be important now in a while. So this is the key part of the ratio test, calculating this expression here. Well, first off, let's sort of say it's the absolute value of u of n plus 1 divided by u of n. Or in other words, we can actually multiply it by 1 over u of n. Okay, so it's actually simpler when you do it this way because the terms are a bit clearer. So what I'm going to do here, they're more spread out. 5 over n plus 1. No, what am I doing here? Yeah, 5 over n plus 1 over n plus 1 times n factorial. That's u of n. Okay, I'm going to put this 5 term out here. Okay, so that way there we have u of n. Okay, and what we're going to do now is multiply by 1 over u of n. So this is n factorial times over 5 to the n. Okay, now what I'm going to do is to cancel out some terms. 5 over n, that cancels out. Or 5 to the n, that cancels out. And n factorial cancels out. So what are we left with? We are left with n plus 1. Okay, so what we're left with is 5 over n plus 1, the absolute value of that. Okay, so the operation now, this is the ratio test, is get the limit of the absolute value of u of n plus 1 divided by u of n. So this is 5 over n plus 1. Okay, what we have to do is get the limit of that. Now the highest power above and below in terms of n, as n goes to infinity, essentially what we do here is get the highest power of n, and it is n. So what we'll do is divide above and below by n. So we have 5 over n over n over n plus 1 over n. And as n goes to infinity, this becomes 0. N divided by n, that becomes 1. And that becomes 0. So essentially what we have here is 0 over 1 plus 0. And no matter which way you cut it, that's always going to be 0. Okay, so the limit is 0. Okay, L is 0. Okay, Now, if L is less than 1, by the way, don't be worried if you get a 0, because that's a perfectly sort of plausible answer for this sort of problem. If L is less than 1, series is convergent. That is actually the case we have here. L is less than 1, so we can say that the series is convergent. So that is the job done, okay? The thing about it being 0 is, what does that mean? Is it that some sort of threshold, or is there some special significance about it being 0? Not really. If it's 1, then yes. But if it's greater than 1, that we might be interested in that. If it's equal to 1, we might be interested in that. If it's less than 1, we're interested in that. But the fact that 0 is not really particularly important. So, that is the ratio test.